I did number 9 already this morning with my block A, so I'm just going to walk you through my approach. All right? Number 9 from the homework, I said, all right, they want me to find the coefficient of friction, mu, so I wrote that down. Find the coefficient of friction. And I decided to draw a picture. So I drew the ramp, 10-degree angle. It said that the object was sliding up the ramp, so I drew the block at the bottom of the ramp, and I said it's apparently sliding 4.06 meters up the ramp. You okay with that? Then I said, okay, you know what? They gave me a distance of 4.06. I also underlined stalks. I said that's going to be a V final of 0. They also gave me an initial velocity of 4. I made a mental note that I could find an acceleration. In fact, I said, I'll bet you I'm going to start solving this with forces, but I'll need the acceleration, and I think I can find it. So I labeled my forces gravity down. We're sliding up the hill, so friction is pointing down the hill. I broke gravity up into its components. Normal force. Who's winning? I said, well, if it's slowing down, it's accelerating down the ramp. I know it's moving up the ramp, but it's accelerating down the ramp because it's slowing down. So I said anything down the ramp is going to be a winner, plus. And so I ended up with both friction and mg parallel, with both friction and mg parallel being winner plus. Is that okay? And then I said, okay, friction is what times what, mu times the normal force. Mg parallel, I wrote again, I dropped that down. I don't know the normal force. Oh, but look. I know another force the same size as the normal force, mg perpendicular. So I dropped that here, and conveniently the mass is canceled. I could have canceled them out on the next line, but the m's canceled. I said, okay, g perpendicular of cos it is, that's going to be cosine. G parallel, that's going to be sine. That equals A. Is that all right, Adrian? So good? Yep. I got the mu by itself, so I minus g sine from both sides, divide by g cos, and I said, now there's an expression for mu. I know g, 9.8. I know theta, 10. I said, I need A. So now I walked over here, and I said, okay, V final is 0, distance is 4.06, V initial is 4, A equals, I used VF squared equals VI squared plus 2AD to find A. I got a negative acceleration, but when I walk that over here, I'll chuck the negative because in the forces section, Courtney, I did let down the ramp be positive. I let that be the winner. So even though I got a negative acceleration from kinematics, I would not put a negative in for the acceleration there. But then that'll work. If you go 1.97 minus 9.8 sine of 10 divided by 9.8 times cos of 10, you do get your minimum coefficient of friction. And then I paused in block A and I said, did I do anything new? I would argue I didn't do anything new. There is going to be a question on your test where there's going to be an angle, and you're going to have to do something with our first unit, kinematics, either using VF equals VI plus AT, or D equals VIT plus half AT squared, or VF squared equals VI squared plus 2AD, and forces winner minus loser. Either I'll make you calculate the acceleration using forces, and then once you have the acceleration, I'll ask you to find a time or a distance or a velocity. Or I'll give you the information about the distance, velocity, or the time, and you can use that to find the acceleration and find something else in the forces equation. Is that okay? Michael, you asked me this one too, yeah or not?
No.
Oh, I thought you said you hadn't got number 9. Okay, just over here. Okay. Any others? So again, if you have questions, you can hit me up during the flex block. Otherwise, if you'd be so kind as to hand in lesson 6, we are going to move on. Our plan of attack right now is I'm going to finish lesson 7 off today. Wednesday, I should finish lesson 8 off. That finishes the unit next week. So I don't see you Wednesday, sorry. Monday, I'll finish off lesson 8. Next week, you'll also get a take-home quiz. Your test is not going to be next week. It's going to be the week after on forces, okay? And all I'm going to be doing for the next couple of days is not teaching you anything new, Taylor, is just looking at weird examples, interesting examples with inclines, with slants, with ramps. If I was going to give you a piece of advice, I would strongly encourage you to get out your calculators and during this lesson, try typing some of this stuff in. I've been helping a few kids. Folks, quiet please. I've been helping a few kids during flex block, and a lot of the time it's been calculator errors. They have all the right work, all the right numbers, and all we can conclude is they typed it wrong. So this is your chance to practice some of this stuff. So you want to get a calculator out and try this along with me. I called this advanced inclines. Combining stuff. So example 1. How much force is required to pull this mass up the frictionless ramp at a constant speed? There's a 2-word phrase that's the key to doing this question. What's the 2-word phrase that makes this question way easier?
Constant speed.
You know what? I would probably underline the word constant speed or the phrase constant speed. Because what does that tell us?
Acceleration is 0.
It tells us that the acceleration is 0, which means when I go winner minus loser equals ma, it's going to be winner minus loser equals m0. You know what? It's going to be winner minus loser. In fact, it's going to be winner equals loser. It's going to be winner equals loser. Let's do our free body diagram. What are the forces acting on this 7? Get the obvious one. So I have mg down. I'm going to put the mg on the same side as the pointy part. And right away, I'm going to break gravity up into its components. There's one. There's another one, where we call this mg perpendicular, mg parallel, and this 40 degrees here is the same as that 40 degrees there, and there's my 90-degree right angle. What else? Well, this block is sitting on a surface, so there's going to be a normal force at 90 degrees to the surface. How big? I think the same size as mg perpendicular. That won't always be the case. I'll show you an example later today of one where that wouldn't be the case. What else? Is there friction in this question? Oh, okay. What else? Tension. And in fact, I think that that's what this question is asking me to find, tension. Now, normally I would go winner minus loser, but what's the acceleration, Prith? What did you say?
0.
So really, it's a tie. The other day I said to you, everything up equals everything down when it's a tie. Here, I would say everything up the ramp equals everything down the ramp. So let's just go straight to writing an equation that says that. What are all the forces pointing up the ramp? Tension is equal to, what are all the forces pointing down the ramp?
mg parallel.
There. mg parallel. The symbol for parallel is 2 lines. Which trig function?
Sine.
Sine, right? So this is going to be mg sine theta. And now we can plug in numbers. 7 times 9.8. Is it coming back? Whew, that scares me every time my projector does that. Sine 40 degrees. Mr. Duke, I thought tension canceled. Tension only cancels when you're looking at more than one mass and writing an equation for more than one mass. Here, for a single mass, tension does not cancel. It's going to be 7 times 9.8 times sine 40. 44.1? 44.1 what? Because it's a force. Okay. I could even add, if I needed to, friction. In fact, I think I did for part B, did I not? I did, good. Part B, suppose there's friction. All right, let's add to our free body diagram. Which way would friction be pointing?
Down the ramp.
How do you know? Down the ramp. How do you know? You're right. Okay, friction doesn't act in the opposite direction of acceleration. Friction acts in the opposite direction of motion. Moving up the hill, there's friction. Is it still at a constant speed? Yeah. So, Dylan, I can still say everything up the ramp has to equal everything down the ramp. I can still say everything up the ramp has to equal everything down the ramp. It didn't make it that much tougher. In fact, you know what? They could even have given me an acceleration. They could say, suppose it's accelerating down, suppose it's slowing down or speeding up, whatever, and I could have an MA. I wouldn't have to have a equals 0. I could deal with that. For now, though, they didn't. That makes it nice. It's going to be mg sine theta plus mu times the normal force. Oh, I don't know the normal force. Oh, but look. I know another force the same size. You know what? I didn't say it this morning. I just moved on without saying it. And the look of dumb disappointment on my block A's was so pathetic. I said, okay, apparently they're all waiting for me to say my look. Okay, so look. What is the force the same size as the normal force, mg? Which trig function? Of course it is. So I'm going to get this. Tension is going to be mg sine theta plus mu mg cos theta. Do the masses cancel? There's m in everything, isn't there? Not on the left-hand side, not in tension. In fact, it makes sense. There should be more tension if you're pulling something heavier. Mass shouldn't cancel. If it did, I'd be worried because that doesn't match with my experimental experience, right? Heavier things are tougher to pull. What was the mass? Theta was 40, the mass was 7. Okay. So tension is going to be 7 times 9.8 sine 40 plus 0.65 times 7 times 9.8 cos 40. You know what? I think if I backspace, I already have 7 times 9.8 times sine 40 plus, not minus because they're both in the same direction, 0.65 times 7 times 9.8 cos 40. 78.3? Double check me. Yeah?
Yeah.
Okay. What else could we throw at you? So here's using a bit of tension on an incline. Fair enough. Could give you an Atwood machine on an incline instead of just hanging straight down. Here's two masses connected by a pulley. Two objects are connected as shown. Mass 1 is 12 kilograms. It sits on a horizontal surface that has a coefficient of friction. Mass 2 is 9.8 kilograms, and it sits on a frictionless surface. So I guess the hill is either greased or made of ice. This mass has some friction. Find the acceleration. Here's my first thinking. Is there any way that mass 1 can accelerate to the left? Is there any way that if you leave a mass and tie something to it, that the mass on its own starts lifting up another object and just pulling it? So I'm going to argue it's either completely at rest, possible, or it's accelerating to the right and down. No way it's accelerating left. So I've kind of decided my winner. Now what? Now what? Yeah, let's do my free body, well, I guess label my forces since I'm not rewriting everything. So what are the forces acting on mass 1? Get the obvious one. M1G. More than one mass, so I'll start numbering my masses. Sitting on a surface, so there's normal force number 1. What else? What else? Is there friction? Oh yeah. Which way? So friction. What are the forces acting on mass 2? Get the obvious one.
M2G.
Straight down M2G. So I'm going to put M2G, and then I'm going to break it up into its components. D, 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 right there. He already has, thanks. MG perpendicular and MG parallel. And Kareem, I'm going to remind myself that those two angles are the same. You don't have to color that in, but again, I've learned coloring stuff in, writing stuff down, I'm just so much more relaxed if I can fill in things that I know. I'm much more likely to start to have that mental jump to the things that I don't know. What else? Other forces. Tension, I'll get to that later. I try and go systematically, and so usually right around now I remind myself, especially because I just drew mg perpendicular, I would say, hey, there's a normal force, and you know what? I'll call it normal force number 2 to go with mass number 2, and I should have put 2's on these m's as well, my components. I think I wrote mg and mg. Oh, I added 2's there now. What else? Yeah, you said it. Tension. Friction on the ramp? No. By the way, I could have, and we just have one more force pointing up the hill. What do you want me to find here, Dean?
Tension.
Really?
Or I didn't see A and all that. Acceleration.
Acceleration. I think part B is going to be the tension later on. Oh, you know what? This is like we did for the Atwood machine, Dylan. We're going to write a big force equation for everything. We're going to walk along the rope, which is going to be up the ramp and then level. Hopefully tensions will cancel. They will. We'll solve for A. It's going to be winner minus loser equals the mass of both of them times A. Then we can go look at individual masses and find tension. So I ask my question, who's winning? Who is winning? Who's winning?
MG parallel.
Which M? Because I got 2 M's, please.
MG, M2G parallel.
This is winning. Down the ramp, which means anything that ends up pointing down the ramp, I'll put a plus sign in front of it, winner. Anything that ends up pointing up the ramp, I'll put a minus sign in front of it, loser. So I'm going to get this. M2G parallel. There's going to be a minus tension. There's going to be a plus tension. And I guess there's going to be, a minus friction. And that's going to equal M1 plus M2 times A. You know what, Kareem, look up. I'm going to call it friction force 1 to go with mass 1, just so I'm organized. You guys got a weekend coming up to relax? Let's lose a little tension. Dean, what did you say I'm trying to find? Do you mind? I'm going to get the A by itself on the next line already, because it's going to be divide by the bracket. So you'll see typically it's the next line that I already say I'm going to put the A equals right here, and it's going to be M1 plus M2 on the bottom. M2G parallel, how can I break that down with trig?
Sine.
Which one? Sine or cos?
Sine.
2 lines is sine, right? So it's going to be M2G sine. I'll put a theta there. It's 42. I'll put that in there next. Then I have minus friction. Friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. What? Now, I'm glad, I think it was Kareem made a quiet mistake under his breath. He said, isn't it M2G perpendicular? I think you said that. Wrong mass. Which friction? It's mass 1, so I don't have to get fancy. It's just going to be physics 11, M1G. Common mistake, kids get so component happy, they want to put components in everything. Hey, part of this is a level question, so we can go with good old M1G. And I think now we can plug and chug. M2 was 9.8 and 12. 9.8 times 9.8, they just happen to be the same. Sine of 42 minus 0.17 times 12 times 9.8. No trig function on that one. All divided by 12 plus 9.8. These are the types of questions I encourage you practice typing into your calculator right now, please. By the way, what's the built-in error check? What must this be smaller than as an acceleration? Yeah, we're not in free fall. We're definitely less than free fall. (9.8) times 9.8 times the sine of 42 minus 0.17 times 12 times 9.8 divided by 12 plus 9.8. Did I do typos? I think I'm good. Do you get 2.03? Okay. And it's an acceleration, meters per second squared. What if I got a negative answer here? What that would be telling me is that friction is so big that mass 2 can't pull down the hill. It's at rest. Be telling me I picked the wrong winner, to be perfectly honest. Okay. Find the tension. Oh, to find the tension, I'm going to look at one mass. Ethan, my friend, take a look at both of these. One of these masses is clearly a little cleaner. Which mass is clearly less work, a little cleaner? Don't listen to Kareem because he's trying to set you up. Which one? Yeah, I'd use M1. I'll use the one without components. Okay, looking at M1, which way is M1 accelerating? To the right? Right? Right. So who's winning?
M2.
Looking at M1, only at M1, because to find, our strategy was we find acceleration looking at both masses, but to find tension, we go look at one mass. Sorry?
Tension.
Who's losing?
Friction.
So we're going to get this. Tension minus friction force 1 equals M1A. Oh! Get the tension by itself. Easy peasy. M1A plus friction force number 1. Normally I would say to you, friction is what times what, mu times, look. But you know what? I think I have an expression for friction already in the previous question. So it's going to be M1, which was 12. A, 2.03. Of course, I'm going to use my answer button. Plus 0.17 times 12 times 9.8. Friction is mu times the normal force. I don't know the normal force. Look. But since I happen to have it already sitting up there, I'll just drop it right down. I think it's drop it right down like a domino is what I usually say, isn't it? 12 times answer button plus 0.17 times 12 times 9.8. You get 44.4. And this is tension, so what will the units be here? Newtons, because it's a force. Okay. Before you turn the page, how could I make this tougher? If I really wanted to kick it up a notch, instead of having mass 1 be level, I could have it on a different angle, more components. But that's really all I can think of to make this tougher. And you will run into one like that in your homework. You are, Courtney, on your test, going to see Atwood machine hanging off a cliff where you have a ramp, like example 2. You are going to see that. And so here's my first question. How can you figure out which way this is going to move? It's tougher than you think. Look up, don't write this down. If this was 1 kilogram and this was 90 kilograms, I think the 90 is going to slide down the hill, lifting up the 1. But what if this was 1.5 kilograms? Now I'm not so sure. Oh, and you know what? It probably depends on how steep the ramp is. If the ramp is really flat, you don't have much pulling downwards. If the ramp is really steep, now you have almost vertical. It's almost, oh. How can we tell which way this moves? It's a good question. How would you determine which way this moves? Mass. More specific, please. Wait? No, I want the answer now. He said wait. I said nah, wait. Tough audience. Okay. I would do something before jumping in. I would do something right now to make this way easier. What might I do right now that I've done most of the time on questions like this? Dylan, let's label our forces. Dylan, you know what? Instead of M1 to M2, I'll call it little m and big M. What are the forces acting on little m? Get the obvious one. little mg. What else? Oh, you're ready going to big M now? That's it for little m. What are the forces acting on big M? Get the obvious one. Big mg, and now I'm going to pause, and I'm going to say components, right? There's going to be a normal force. Okay. Eric, I think you were on the right track, but there's a reason I said more specific, because I think you said, well, you just compare mg. You don't. What forces are tugging at each other? Which two forces are actually the ones that are in opposition with each other? One of them is little mg. What's the other one? Big mg parallel. If you want to decide which way this thing is moving, you're going to compare those two forces. You're going to compare mg and big mg, heck, parallel is sine. And so sometimes what I'll do, Nat, if you give me a question like this, before I start to solve it, I'll really quickly crunch mg on my calculator. I'll really quickly crunch the other mg sine on my calculator. Which one's bigger? That's winning. That also tells me which way his friction is pointing, because if this is the winner, I would point friction down the hill if there was some. If this was the winner, I would point friction up the hill. Having said that, it turns out you can guess wrong and you're not in as bad a shape as you think. So you can figure out ahead of time who the winner is, and you guys are strong enough, most of you will probably choose to go that route. You'll draw the free body diagram. You'll say, look, I know the tensions cancel. I'll temporarily ignore friction. Which gravity component is winning? That's perfectly fine. But I'm going to show you, even if you get it wrong, it's not that big a deal. Example 3, same question but with numbers. It says, find the acceleration of this system. Okay. Let's decide ahead of time which way this is moving. Is the 5 kilograms moving up or moving down? Well, I can find out by comparing. It's going to be 5 times 9.8. That's the force, 49 newtons tugging down on the left. On the right-hand side, it's going to be mg parallel, mg 2 lines, mg sine, which m? 8 times 9.8 times sine of 30. And I get 39.2. Which mass is winning? The 5 or the 8? The 5. You know what? Suppose we guessed wrong. I'm going to deliberately, just to show you how to fix it, assume the 8 is winning. It's wrong, but I'll show you how, even if you are wrong, it's easy to tell that you're wrong on your calculator, and it's about a 5-second fix. So I'm going to do this one wrong on purpose, just to let you know it's not the end of the world if you are wrong. I'm going to start this off the same way. How am I going to start this off? So I'm going to have M1G tension. I'm going to have M2G. Guys, you with me? Shush is what I'm really saying, okay? Thanks. I'm going to have M2G perpendicular and M2G parallel. I'll have a normal force number 2 to go with mass number 2. I'll have tension. Now, we already calculated that the 8 is moving up the hill, this is moving down. Suppose you guessed wrong. Suppose you figured, well, the 8's bigger, it's winning. And you have it moving down the hill. Which way would you point friction? Let's draw that in. Okay? So again, Priya, I'm doing this wrong on purpose to show you it's an easy fix. I would now say, what do you want me to find? Acceleration? I would say, who's winning? I decided that this was the winner. Down the ramp is going to be the winner, even though it's wrong. That's okay. I'm going to decide that. So I would write winner. Then I would have minus tension and minus friction, both losers. I would have plus tension minus M1G, and that equals M1 plus M2 times A. Do the tensions still cancel even though we've guessed wrong? Oh, that's nice. Is it still fairly easy to get the A by itself even though we've guessed wrong winner? Well, that's nice. I'm going to do that on the next line. A is going to be, big fraction bar, M1 plus M2. M2G parallel, M2G two lines. Help me out, people. Sine? M2G sine of theta. Then I have minus friction. Friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as normal force number 2, M2G perpendicular. Which trig function? Of course it is. M2G cos. And then I have minus M1G. That just drops down like a domino. Okay? So far, so good. Let's plug in numbers. M2, 8 times 9.8 sine 30 minus 0.05 times 8 times 9.8 cos 30 minus 5 times 9.8 all over. Can I add the 8 and 5 together in my head? 13. All of you, I encourage all of you, Courtney, you too, all of you, try typing this into your calculator. I want you to see how you know you've guessed wrong. Your calculator will tell you with something fairly obvious. What happens on your calculator? You get a negative. That gets your attention, I hope. Okay? So how do you know you've guessed wrong? You get a negative. You get negative 1.01? Yep. So, first of all, Marcus, I'm going to argue, that stands out, yes? Now, no, you've guessed wrong. Easy fix. Down the ramp isn't the winner. What's the winner? Up the ramp. So, this force here, winner or loser? Everybody right now, put a negative, put a negative, put a negative. Fixed. It's a loser, right? I don't need to redraw, rewrite, or redo anything. Now, friction we have pointed the wrong way, so I'm going to scribble out friction. I'm going to point friction down the ramp. Yes? It's a loser. Yes? So should it be negative or positive? You know what? It already was negative. I don't have to change friction. I had a loser the other way too. That's kind of nice. Do the tensions still cancel? Yeah. What about this M1G? Is it a winner or is it a loser? All I'm going to do then, Kareem, is go make it positive, make it positive, make it positive. That's now the right equation. Oh, ready? Have I gone on the rant about getting a good calculator occasionally? So on my calculator, I can just backspace, and if you know how to insert, and you should know, all of your calculators have an insert button. I just got to insert an, I didn't want to do that, Mr. Dewitt. No, I didn't want to do that either. Okay, let's try this again. I can just backspace, if I do this right, insert, I can put a negative there. And I guess the only other change that I had to do was the minus sign in front of the 5 becomes a plus sign. It's a really easy fix if you guess wrong. takes me far long to explain how to fix it than it does to actually fix it. I can usually do it in about 10 seconds. And it's pretty obvious. Whoops, I guessed wrong. 0.493. You okay with that, Adeem? So, for really, really complicated questions, honestly, I won't bother trying to predict ahead of time who the winner is. I'll take a guess, bigger mass, and if I'm wrong, easy to fix. For a question like this, no big deal, but like for something like this, or even if there was like a third mass horizontally in the middle and was really complicated, I'll take a guess, and if I'm wrong, I'll go fix it. Find the tension. Once again, I'm going to argue, Ethan, that one of these masses is way less ugly than the other mass. How would I find tension? Which mass would I use? The 5 or the 8? Even though tension's a loser in the 5, it's still going to be way easier. So my equation for the 5 kilogram mass is going to be winner. Try that again. Winner minus tension equals M1A. It's a simple step to get the tension by itself. We've done this dance before, have we not? Tension is going to be M1G minus M1A. It's going to be 5 times 9.8 minus 5. I'll write 0.493. Of course, I'll use my answer button. 5 times 9.8 minus 5 times answer button. And I get 46.5 newtons. You would get the same tension with the other mass. You'd be doing a lot more trig components and stuff, so why bother? Okay. Last one. This is about as tough as I can throw at you. Well, okay. The only way I could make this question tougher was instead of having mass 1 hang straight down, I could have it on a ramp with a different angle, different components. It's really all I can do. What are they asking me to find here, Marcus, in part A? What are they asking me to find in part B? You know what, Courtney? This is like, you might recall when we did the Atwood machine, we finished off doing questions to find the mass where we ended up with 2 masses in our equation. We said, oh, we would like to have 1 mass. We got them to the same side. We pulled out a grade 9 mathematical operation, factored out an m, and we're able to get the m by itself. Our strategy was this. If they don't tell us, if they give us both masses, I'll write an equation for both masses, winner minus loser, and I can find the acceleration. If they only give me 1 mass, they're either going to tell me the acceleration or the tension in the question. They told me the acceleration. And I'm going to start out looking at 1 mass. And then hopefully I can find something from the mass that I know that I can use to find the mass that I don't know. You with me? Marcus, how am I going to start? Sure. What are the forces acting on mass 1? Get the obvious one. What else? Good. Normal force? No, it's hanging in midair. Friction? No, it's hanging in midair. Mass 2. It's on a ramp, yes. Components. M2G perpendicular. M2G parallel. That angle here and that angle. What is that angle? 28 degrees. I guess I should write that on the diagram just so I don't forget. What else? Yep. Same size as... Mr. Dewick, I thought you said you were going to show us an example where the normal force was a different... Oh, I can show you one in the homework. Right here. You're partly pushing down. Your normal force is going to get bigger. In fact, what you would do is you would break this 120 up into a horizontal and into a vertical component. Preview of coming attractions. Meanwhile, back here. What else? Which way? Is there friction? Which way? And now we have to read carefully. They have to tell me which way we're moving, which way we're accelerating. Which way is mass 1 accelerating? Which way is mass 1 accelerating? So which way is mass 2 accelerating? Which way is friction pointing? Beautiful. They have to tell me that. Okay. Which mass don't I know? I'm leaving that alone for a while. What do they want me to find in part A? Marcus? Let's write an equation for the mass that I know, mass 1. And if we're lucky, we'll be able to find tension. Looking at mass 1, Marcus, my friend, who's winning? How do you know? This is why they had to tell me. They had to tell me that it was accelerating upwards. If they don't give me that piece of information, this question is not solvable. Unless they say it's at rest, then it's solvable because they've snuck that in, then I know A is 0. So you're telling me tension minus M1G equals M1A? Let's see if we can find tension. Get the T by itself. Tension is going to be M1A plus M1G. Marcus, do I know mass 1? Do I know A? They had to tell. They told me in the question. In the yes, they did. And I know G. Okay, this is why they had to tell me that part. So mass 1 was 8. 2.1 plus 8 times 9.8. You know what? That I should be able to do in my head. Factor out on 8. 9.8 plus 2.1 is going to be 11.9. It's going to be 88 plus 7.2. 95.2?
Yep.
There we go. A little worried there. Okay. Michael, what's part B you want me to find?
Mass 2.
Hey, let's write an equation for mass 2. Hopefully there's an M in there that we can solve for. So looking at mass 2, Michael, my friend, who's winning?
Mass 2 parallel.
M2G parallel. So down the ramp is going to be winner plus. Any other winners? Nope. Who's losing?
Tension
And that's going to equal M2A. I think, Adim, I'm going to go parallel sign. Oh, friction. Friction is what times what? I don't know the normal force. Oh, but look. So you know what? This is complicated enough. I'm going to show all my steps here. I'm not going to risk taking shortcuts. So I'm going to carefully go M2G parallel minus tension minus mu M2G perpendicular. That equals M2A. Now let's do our trig. Parallel sine perpendicular of course it is. Right? I hope. So it's going to be M2G sine theta minus tension minus M2G cos theta. That equals M2A. Minus mu. You're right. What's mu? I don't know. What's mu with you? Jeez. Thank you. Michael, what am I trying to find?
Mass 2.
How many M2s are there in my equation right now? 3. How many would I prefer?
1.
Let's get them all to the same side. You know, I'm going to do this. I'm going to plus the tension over because that gets rid of a negative. I'll take that. And I'll minus M2A over. Is that okay? We've done that a bunch of times. So it's going to be M2G sine theta minus mu M2G cos theta minus M2A. That equals tension. How many mass 2s are there in my equation, Michael?
3.
How many would I prefer? You know what would be really cool? It would be cool if there was a grade 9 mathematical operation that I could pull out of my back pocket that would somehow make this go from 3 into 1. What? Factoring. I can factor out an M2. This is going to be M2 G sine minus mu G cos minus A That's going to be your hip-hop gang handle, is it? You can just call me G sign. Uh-huh. I'm not the opposite, I'm the hypotenuse. Uh-huh. You could even be the hypotenuse. Huh? Eh? Huh?
It's so cringe.
Oh, it's so bad. Although you know what? I'm envisioning next year the nerdiest Halloween costume ever. I got to ponder this and see what I can do with that. Oh yeah, the rap star hypotenuse. I think that would be pretty good. G sign. Hey, how would I get the M2 by itself? People on YouTube are going to be going, what the heck? Yeah, whatever. How do I get the M2 by itself? Yeah, we've done the hard stuff now, I think. So it's going to be tension divided by G sine theta minus mu G cos theta minus A. What was it, 95.2 was the tension. All over. Am I going to be able to fit this in? I hope so. 9.8 sine, what was the angle? 28 minus, what's mu? I don't remember. 0.12 times 9.8 cos 28 minus, and acceleration was 2.1, wasn't it? Yeah. Again, I strongly encourage you, practice typing that into your calculator. I think if I recall, this one works out almost but not quite evenly, which tells you what I probably started out with when I made up this question. Check my brackets, because last time I did this I missed one. It's going to be G sine 28 minus mu G cos 28 minus, you get 65.1? Yeah, kilos. Okay. What's your homework? Here's what I assigned my block A's. Okay. Number 1. Okay. I did give you the mu right there. I just wrote it out because I couldn't find the mu symbol on my keyboard at that point. So number 1. Number 2. Number 3, I put a star next to. That's probably a little tougher than I'll ask you. So unlike the one that we just did where one of the masses was handing straight down, here is find a missing mass where they both have different angles. Different components. I don't know. Number 4. Okay. I'm not going to assign number 5. It's cool, but that's a little overkill. 7 and 8. And then 12 and 13.